So welcome to the team assignment midterm. The students who made this video are Silva and Lucia Mendoza. I'm Lucia and I'm going to explain the first half of this presentation. So let's start with the intro, right? So let's talk about a high-level programming language, which is a term that describes language that have been abstracted to become more programmer-friendly than the old ones that used lengthy series of ones and zeros to program. Some of the programs that programmers use in these days are Java and HTML and other ones. So let's talk about NetBeans, GitHub, and Visual Paradigm. So NetBeans is designed to make programming easier for the person writing the code. Like NetBeans can help you to find errors and NetBeans display those errors to the programmer. Programming IDs can greatly decrease the amount of time a programmer must spend in the development stage. Also, by communicating with the Java compiler, the NetBeans ID allows programmers to run the code directly in the NetBeans environment, allowing you to run your code and see the result almost instantly. Just a few seconds is needed, and all from within NetBeans itself. So, yeah, programmers used to work in team, and to work in team you need to some way to back up and share the code that the entire team is working on. And library systems have been developed and are used daily by programmers to help manage the code that they write, and that is GitHub. GitHub is one of the most popular library systems. Now how to work with GitHub is really important in these days for programmers. Programmers can upload and back up their code to the internet, where it can be accessed by either a selection of others, like a private hosting, or to the general public in a public hosting. GitHub stores your code in what are called repositories. Repositories allow you to organize and store your code in a way that your professor and others will be able to retrieve and update. For this course, GitHub will be and are used. Visual Paradigm are used to create UML diagrams. So these are the programs that we have used to make the many assignments that we had in this course. So let's skip. Let's talk about software design principles. So let's say that there are 3 key principles. Use a proven development process, get feedback to improve design, and use refining iterations. And those are the 3 key principles. Now let's talk about the 5 phases of the development process. First is define. Define the problem. And then get the agreement with the client. User stories. I will talk about user stories a little later. So let's talk about the design. Design a solution to the problem, right? Now develop. This is the third one. Develop or construct the system. Now test the system, and the last one, but not less important, deploy the system to the user or the client. So let's skip. So let's start writing a program. To start writing a program, we need to define program requirements. That starts in the define phase, because we define the problem. So, how I can see it. Defining the requirements for the game program These requirements are to be documented in a series of end-user stories that describe the play of your game, of the program you are doing, right? Now, end-user story. End-user story is part in the define phase, and they define the problem, define what the program has to do and how it has to respond when the user have when the user play or game. So each end user story should describe or display what the end user sees on the screen, what actions the end user takes, and what the program does in response to each valid and invalid action the end users may take. Now don't worry too much about getting the requirements and design perfect in the first iteration is what we have learned while we were doing end user story, because we have changed the anyway. So this is an example of the Oregon Trail software requirements. This is the main menu end user story. If you can see it, it says the menu that it displayed. It says how the end user sees in the screen, what actions the end user takes, and what the program does in response to that actions. Right? So let's talk now about the UML. So in the design phase, programmers normally create UML class to define and document the classes used in a program. This type of diagram illustrates each of the classes and the relationships that naturally exist between the classes. So these squares are the classes, our player, our map, our game. Those are the classes, and those classes have relationships that are here. Our association, dependency, inheritance, has association too. This is like many classes, realization, navigate, these are the UML class diagrams relationships types that you can use to relation your classes. Now also, to create a UML diagram, we need symbols used to define cardinality. So the minimal cardinality, the first number, determines whether it is optional or required to have at least one instance. If the first number is 0, means that it's optional. A minimal cardinality of 1 means that it's required to have at least one object instance. So let's see this example of here. There is 0 and there is 1. And this means that 0 to many games can have at least one map. And my teammate Amon will keep explaining a little more of my teammate Amon will keep with the explanation. Thank you.
I will talk to you about defining functions, control layers, and the view layers. So let's start with it. The first thing that I want to talk with you is the encapsulation. Encapsulation is a technique of programming to make your class more modular. It means that you can reuse this class for other projects or to use it for other kinds of things to make um, less changes in the class. You can establish it when you put all the attributes like private and you make all the changes in this object by his functions. For example, here I will explain what is a function and when we call and how we can call it. The first thing that we have in a function is the function signature. The function signature explains what is your function. For example, we can explain the modifier if everyone can access it or no one can access it, only who are inside the class for can access this kind of function. The modifier is the word public, private, or protect. It can define who are accessing our function. The data type is the second thing in our function signature. We can explain for who are calling our functions, if your function are returning a string, a number, like integer, float, double, it's depending on the kind of function that we have. For example, I can have a function to concatenate a name. So I can introduce my first name and I can introduce my last name. And the function can return to me a string, join the first name plus space plus the last name. So the third part is the name of function. It is one of the main things in the function signature because when we call the function, we will type his name and open and close the parentheses. We will call his name, we will type his name, and inside these parentheses, we will introduce all the parameters, the list of parameters that the function requires of us, because the list of parameters is the types of values that the function will use to produce his result to us. So, for example, we have some functions that have the word return. These kinds of functions is these functions when we return a value. We define it in the data type. For example, I talk about a function that can return a name, a concatenation of names. For each, we need to have a return of this string or concatenate charge. We need to return specifying the charge that we want to return. But in the example below, we have a public void. And the return with void, it means that we don't need a return here. This function, we want to do an action, but we will not return for who are calling him. For example, here we have the modifier public. Data type we don't have, we establish as void. We will not return nothing. We have the name is high, and we have the list of parameters. We have a type of parameters name. The other type is int, age, and what this function will do is to print to the display high plus the name plus space plus the age of the person. Control layers. Control layers is the control layers is class that is responsible for all the actions and behavior in our program. For example, the control layers is responsible to do calculations, make decisions, and retrieve data, and from the objects in the model layers, for example. We have some considerations to do a control layer. We need to establish one task for each control layer. It makes more organized your code. It can avoid some mistakes and misunderstood for your team, for example. And it can facilitate many things when we divide and conquer. We have here a sign. When we have the control layer and the model layers, we have the use. The user relationships is this kind of a dashed arrow. I will show you to here. We have the same kind here. We have a game and the game control. The game control is the control class. It is have a user relationship with the game, the model game class. Okay, let's continue. We have how we can create a control layer. The first thing that we need is to clearly define the problem. We'll talk about each of these steps. So clearly define the problem. We need to ask for ourselves when are reading the end user story, what exactly must this function do? We have a problem, and what this problem is, what this function needs to do to solve it. What inputs are needed? What is input to be returned? We can try to draw it as is below. We have to create a test matrix. The test matrix is a when we are testing all the parameters that we established. We put the valid inputs. What is the invalid input? What values our function will not work with? It will break, and we need to send a error message. What is the boundaries of your function? We have to establish the outline solutions. It means that we need to create an algorithm for a function. And the algorithm is algorithm is steps to follow to solve a problem. And usually we can use a pseudocode. A pseudocode is not a machine language, but is a language more like the real life language. We can express these steps not matter what is the rules of the programming language. Creating a controller. Here we have a algorithm. For example, I crop this part so you can see here we have the name, the parameter listers. We have a begin, and here don't show to you, but we have the end also. We have a integer, etc. It's a pseudocode language. It's not a programming language, for example. Creating, testing the algorithm. The follow step is that we need to test our algorithm. We can test it with the test case. The test case, uh, we can make our all tests, but that we had did. We will input the values of your test metrics to our test case. In the test case, we have all the variables and all the values that each will happen when the function are working, and we will input it during the test. Here we have an example. For example, we have the variable actor quantity, actor health, player found, player occupation, punctuations is a variable inside the function also. We will input all the values into it, and what will be the result when we are processing our function. The step 5 is to translate to code. Here we have some more one sample. We have the algorithm, we have the function signatory, we have here the function signatory also. We can compare it. Begin will be the curly brace, integer, etc. Creating the controller. So here we establish the step 6 and 7. The step 6 is to run a test case of your language program. Now we can use the JUnit in the NetBeans to explain to do example of it. So choose the JUnit. We need to do the follow. We'll go to the control package that we have here. We'll click with the right button of the mouse. We'll go to tools, create and update tests. We have this class below, so I will exclude it, delete it. Tools, create, or update. Now I will create a test. If you don't have this screen, probably the NetBeans will ask you to install the JUnit 3 or 4. It is considered to install the 4, the last version. Okay, here we have the code for a test. Here we have the values that we start, and here we can input the values of our text matrix. Input the test matrix values, we can see if you will output or expected result in your text matrix. Let's go here. Here I have the example already. So I will restore it to here. So here we have. So we can now right click and text file, test file. Okay, we have the test one that I have established here. Oops, sorry. Test two, but after it we have an error, and this expected as the invalid inputs. Okay. So let's start. The seventh step is to deploy the change to repository. So if everything are working well, we can deploy it. We can send it to the GitHub for our team to continue to work or to finish your project. So the view layers. The view layers, we have three things that we divide. The first is to retrieve the inputs. Usually we do an input function to retrieve all the inputs of the user. The second thing is to perform the desired action. For this step, we have the do action function, and we display the next view. And in this part, we display the view with the function display. Um, each of these functions is to divide and conquer. This is the purpose why we divide all these steps of the view layer. So I hope that I could explain well and everyone could understand well this explanation about what we had learned in this magic course. See you.